Hello again, and this is my second video on my fractions topic. We're looking at simplifying and comparing fractions. So when we simplify a fraction, what we're trying to do is break it down to its lowest terms. So ideally, you'll find the highest common factor of the numerator and denominator and divide by that. So let's have a look at the first one. 6 over 8. I can see the highest common factor of 6 and 8 is 2. So I'm going to divide by 2 the numerator, how many 2's go into 6, and the denominator, how many 2's go into 8, and I broke that down to its simplest form. Let's try the next one. So ideally, like I said, you're looking for the highest common factor, and when I look at these two numbers, I can see 3 goes into both of these numbers, and 3 is actually the highest common factor. So divide both numerator and denominator by 3. How many 3's go into 9? How many 3's go into 12? And there you have it, we've broken it down to its simplest form. Let's try the next one. And this is easy to see that 40 is the highest common factor. 40 goes into both of these numbers, so we're going to divide by 40. How many 40's go into 40? 1. How many 40's go into 80? 2. So I've broken this fraction down to a simplest form. Let's do another one. Looking at these two, I can see the highest common factor is 6. So I'm going to divide both numerator and denominator by 6. How many 6's go into 24? How many 6's go into 30? So 24 over 30 in the simplest form is 4/5. So it's much easier if you can identify the highest common factor. It takes you straight to the simplest form. But if you can't see the highest common factor, you can go the long way around and you'll still get all the marks in a test, in an exam. So let's just do that one again, but we won't go straight to the highest common factor. So this is the same one as the one above. But let's say I can't identify the highest common factor, but I can see that they're both even numbers. So I know they can both be divided by 2. So that's what I'm going to do. I'm going to divide both numerator and denominator by 2. So 24 over 30 becomes 12 over 15. So what I've done, I've divided by 2 on the numerator and the denominator. And remember, you must do the same thing to the numerator and denominator to maintain that equivalence, to find an equivalent fraction. So please watch my video 1 on equivalent fractions if you've not watched that yet. But as we know we've not got down to the simplest form. So looking at these two numbers, I know they can't be divided by 2. This one, the denominator can't be divided by 2 because it's an odd number. Does 3 go into both of these numbers? So let's have a look. Well, 2 and 1 adds up to 3. So 3 goes into 3. That means 3 will go into this number. Does 3 go into this number? 5 and 1 is 6, and 3 goes into 6. So yes, 3 will go into this. So I'm going to divide both of these numbers by 3. How many 3's go into 12? How many 3's go into 15? And as you can see, we've got the same answer as we did before. We just went the long way around. So we divided this time by 3. The numerator and denominator by 3. Let's try some more of them. Let's try 123 divided by 441. This is a bigger number. So looking at these two numbers, these are odd numbers, so they can't be divided by 2, not to get a whole number. So can they be divided by 3? So remember our little trick. To see if this number can be divided by 3, you just add the digits together. And then if that total can be divided by 3, then so can this number. So 3, 4, 5, 6. That number, then digits add up to 6. So 3 goes into 6, so 3 will go into this. Does 3 go into 441? Add the digits together. 4 plus 4 plus 1 is 9. Then digits would add up to 9. So I know this is divisible by 3 because 9 is divisible by 3. So let's go ahead and divide numerator and denominator by 3. How many 3's go into 123? That would be 41. How many 3's go into 441? That would be 147. So I've divided both numerator and denominator by 3 because you do have to do the same to both to maintain that equivalence. And we've got 41 over 147. And I know this is the simplest form because this is a prime number, and a prime number only has 2 factors. But 41 will not go into this exactly, so this is its simplest form. So that's simplifying fractions. Here's some exam style questions we can look at together. So same processes. This is what an exam question might look like. Write the following in their simplest form. So again, if you can go straight to the highest common factor, that would save you a lot of time. And I can see these can both be divided by 12. So I'm going to divide numerator and denominator by 12. 12 goes into 12 once, 12 goes into 65 times. So that's in the simplest form. 18 over 40. I can see they're both even numbers, so I'm going to divide them both by 2. And that's the simplest form. So let's look at this one. Well, looking at these two numbers, I can see they're both even numbers. So I'm just going to divide them both by 2 to start with. So I've not found the highest common factor. How many 2's go into this? 14. How many 2's go into 36? 18. But I can see looking at these, I can still divide by 2 again. So I'm going to divide both by 2 again. And there you go. I've took it right down to its simplest form. So you don't have to find the highest common factor and divide by that. You can break it down step at a time until you get to your simplest form. So there are some type of questions you might see in an exam. So let's compare some fractions. So to compare some fractions, so you're asked a lot of the time to compare fractions. So what fraction is closest to 1? So we're going to compare. Look at these top two here. So before you can compare fractions, you have to make these denominators the same. So if I multiply these denominators, I can get a new denominator of 15 for both of them. And that's what I'm going to do. I'm going to change them both to a denominator of 15. So as we know, whatever you've done to the denominator, you do the same to the numerator. This denominator was multiplied by 3, so I must do the same to the numerator. So this, an equivalent fraction to this, 3 2's are 6. So 6 15ths is equal to 2 fifths. This denominator, to make it a 15, was multiplied by 5, so I must do the same to the numerator. That's 10. So now I can see which is the smallest fraction. That's 6 15ths, that's 10 15ths. But which one is closest to 1? Well, because we're working with 15ths, I'm going to say which is closest to 15 over 15, because any number over itself equals 1. I can see this fraction here is 10 15ths. So if I say 15 15ths take away 10 15ths, there's a difference between this one and this one of 5 15ths. This one is 6 15ths. So if I say 15 15ths take away 6 15ths would be 9 15ths, a difference of 9 15ths. So this is 9 15ths away from 1, and this is 5 15ths away from 1. So 2/3 is closest to 1. 2/3 closest to 1. So let's try this one here. So which is closest to 1, 7/8 or 4/5? So before we can compare them, we have to add them together to see, so we can compare them. So not add them together, sorry, multiply these denominators to get a new denominator of 40. So I've changed the denominators to 40. This was being multiplied by 5, so I must multiply the numerator by 5. This was multiplied by 8, so I must multiply the numerator by 8. So now I can see this is 32 40ths, this is 35 40ths, which is closer to 1. Because I'm working with 40ths, I'm going to say which is closer to 40 over 40, because that equals 1. This is 8 away, that's 8 40ths away. The difference between this and this is 5 40ths away. So this one must be closer to 1 because it's only 5 40ths away. So we can say 7/8 is closest to 1. So one more style of question that you might see comparing fractions. You might be given a question like this. When comparing, write in ascending order. Ascending means right from the smallest to the largest. So look at the denominators, and you have to make all these denominators the same as each other to be able to compare. So if you look at these other denominators, first of all, look at the largest one. Are these other denominators factors of 30? Yes, they are. So I can make all these denominators 30. But remember, whatever I did to the denominator, I must do the same to the numerator. This denominator hasn't changed, so I don't change the numerator. This denominator has been multiplied by 5 to make it 30. So multiply the numerator by 5. This denominator has been multiplied by 10, so multiply the numerator by 10. This denominator being multiplied by 2, multiply the numerator by 2. This denominator is being multiplied by 6, multiply the numerator by 6. And now, because they're all over 30, I can see which is the smallest. Just look at the numerators. So 18/30 is the smallest, so write it as it appeared in the question. So then we've got 19/30, next smallest, because I write them order ascending, and then you've got 2/3, 11/15, and finally 5/6. So that is order ascending. So thank you for watching. Please subscribe if you like my videos to help my channel to grow, and check out my other videos on fractions.